once we get recorded. There we go. Awesome. All right. So yeah, as always, thank you all for being here. Probably looks like our last week, hopefully, of being full remote. The way it looks is that we are coming back hybrid starting on Monday. This is certainly a school year where nothing is set in stone, but that's the way it looks right now. My guess is that we will probably go back to that schedule that we were in before Thanksgiving, right? Cohort A Monday, Wednesdays, and cohort B Tuesday, Thursdays will come into school. I don't think cohorts will have changed at all in terms of which cohort you were in, and then Fridays, of course, will be all remote. Not sure what that means for us in terms of having to log in separately, like what do we want to do? I think that's just going to be different for every class, but I'll get a little closer to that decision once today and tomorrow gets finished up, especially with tomorrow being registration day. And us having kind of just a different schedule and me kind of having to bounce around to each of you individually to see what that last final decision is that you want to take for next year. And for seniors, obviously, you won't have to worry about that. But for everybody else, we will jump into individual breakout groups on this Google Meet. There's a way that I can drop you into your own separate space so that you and I can talk one-on-one. Just to make sure that whatever decision you and I have come to at this point, that we are good to go. And I'm still waiting on responses from a handful of you. Either things were kind of up in the air and you weren't sure which class to take, or you didn't even respond to my initial survey. So I have no idea what you want to do. There is a lot of open messages in my Canvas inbox that I'm waiting to hear back on. So if you are in limbo at the moment, please respond so I can help figure that out for you so that tomorrow goes quickly. There's 30 of us, and I want things to happen quickly. I don't want somebody having to wait around a half hour just for me to get to them. If we can go through it faster, that saves the people at the end from having to wait around quite so much. So do me a solid and either answer that message in your Canvas inbox that's still unanswered, or fill out that survey or something. I will send one more round of messages later tonight if I don't hear back from you, hopefully. That won't be something I have to do. But that's that, okay? The schedule for tomorrow is different than it ever has been because they're taking all of that homeroom time that was between 4th and 5th, and they're front loading it. So if you have a first period class, you'll go to that at 7:40. If you don't, but you have a second period class, you'll go to that one just to watch the counseling registration video at 7:40 with your second period teacher at 7:40. Okay, even though class for second period doesn't start until 9:10. Okay, for us in 7th, class won't start tomorrow until 1:20. I'll make sure I put the schedule up on Canvas so you can see that, and I'll make sure that the announcement also says 1:20 instead of our regular 1:10. Okay, and we'll just knock out registration as quickly as we can. The video for that counseling put together for registration should answer all of the how do I kind of questions. But the what class should I take questions at this point are hopefully all figured out between you and your teacher for each specific class, whatever that might be. Okay.
Mr. Rosengren?
Yeah, hit me.
If you have second period off, what do you do?
Do you have a first period?
I do.
Then go to first.
Okay.
Then you should be good. It's just for the people that don't have a first period class. They'll just go to the second period class right at the beginning of the day just to watch that video.
Okay, thank you.
If you have a first, then you'll just go to first like you normally would. Cool. So that's the plan for tomorrow. And then we'll kind of see where that gets us for Thursday and beyond. And then Monday, hopefully, cohort A, I'll see you guys in person, which is really cool. I'm going to have to rearrange this classroom a little bit because I definitely have it set up for remote learning with desks up on chairs so I can point them at the boards. I finally figured this whole thing out. But it'll be really good to see you guys in person. So cool. So that's the deal for that. Hopefully you have all of your questions answered. If you don't, then ask them either right now or later. That's fine too. But what I want to do today is go back to Thursday and Friday stuff that we were working with, knowing that is still a little bit tricky for us. I saw that a lot of people have not yet submitted that classwork 2.5a. That was our work for Friday, but people had reached out to tell me why, and it was because they just weren't sure how to do it, which is fine because we're just learning this stuff for the first time. So that's what I want to do today. If you did that work, that 2.5a classwork, take it out. But if you didn't get a chance to do that, we're going to do it together right now, and you can submit it for some credit. Okay. I want to make sure that all of those questions that maybe are unanswered in your minds right now, hopefully can get answered here in the next 10 minutes as I work through those two problems, maybe 15, okay? Then I'll give you 2 to try on your own, call it 2.5b, and we'll go from there, okay? So if there's something that I say that, that is confusing about this, or that you just don't get as I'm working through it, just stop me. Raise a hand virtually. You can click that raise a hand button, or just drop a message in the chat, or unmute yourself and slow me down, okay? Because I want you to feel like you're getting it. For anybody that is dealing with, if you're like Carson said, if you're on your phone watching this and you can't do breakout rooms, let me know, Carson. I'll talk to you separately. I think we've kind of already made our choice, but in case we need to shore it up, I'll just message you on camera or something like that. We'll figure it out. Okay, but let's do it. Take out that classwork from Friday if you did it, or if you didn't, let's do it all together right now. I'm gonna pull it up on my computer so I can see what I'm working with. And throughout this process, I want to kind of reteach how to do it, which is just following these steps that are over here, okay? But I know doing it with me is one thing, doing it on your own is something else. So let's do it together, okay? Here we go. Number 1. Okay, so this was 2.5a, right? This is classwork 2.5a. And if you didn't get a chance to submit it, make sure that you jot these 2 down as we go through them, then take a picture, throw it up on Canvas so I can give you some credit for it, and then you'll separately do 2.5b and you'll upload that, okay? But please remember, whatever you put on Canvas, I want you to handwrite it if possible, okay? But your name's gotta be on it too, okay? I wanna see the work. I wanna see it actually happen, okay? Giving you credit for things that you are not doing is not something I'm fond of. Okay, so I want to see you actually work this stuff out, okay? Because the test that we'll eventually take on this is going to happen in class if we're back to hybrid. So if you are not putting in the work now, you're not going to do on the test that counts for way more than some homework out of 20 or 25 that we'll end up doing throughout the semester. Cool, here we go. All right, so the first question was, all right, they gave us a function, x squared plus 6x minus 1. And they said to find the x-intercepts, right? Given the following quadratic equation, find the x-intercepts. And so that's, I don't care how you do it, factoring this way, the thing that I'll teach you next week, I don't care how you do it, it's all kind of start by setting it equal to 0. Now, what that means is the f of x part disappears, because that's the whole graph. I don't care about the whole thing. I just want the x-intercept. So I'm going to take the x squared plus 6x minus 1, and I'm going to set it equal to 0. You only want one equal sign in the whole equation. So I don't want like f of x equals all of this equals. It's like some big run-on sentence, and I don't know where one ends and the other one begins. So set it equal to 0, and then think for a second. Like, I would love to factor this if I could, right? But all right, well, let's see what we've got, right? A is 1, B is 6, and C is -1, right? Because that's ax squared plus bx plus c, but 2 numbers that add to 6 and multiply to -1? No, I don't think so. The only way to multiply to -1 is 1 and -1, and that's certainly not going to add up to 6. So it's not factorable. Now, if it was, that's definitely the way I'm going to do it. Factoring is the easiest way to solve these, because then you just put them in 2 separate parentheses and set them equal to 0 and see what you get. But this, no good. It's okay. It doesn't mean there aren't x-intercepts. It just means they're not going to land at really nice spots. And we just want to find those not so nice spots, and we figured out a great way to do that. And it kind of goes back to what's in blue right here, having both an x and an x squared. I really can't solve an equation that's got both if it's not factorable, right? I want to get to x equals because there's x-intercepts. And so what we figured out on Thursday is that, hey, you know what? If I could rewrite it in vertex form instead, where there's only one x in the whole problem, well, then I can go solve it, right? Chapter 0, give me any equation, only one variable, I can solve it just by undoing what's happening. Well, to write it in vertex form, I got to find the vertex. So that's kind of where I start. Now, I like to kind of just like continue my work this way, like one equation, just kind of like do some of the equations, like step, equation, step, equation, step, equation, step, equation, yay, I'm done, and I finally get to x equals. This work is kind of separate from that, right? So what I like to do is I'll just kind of come off on the side here, so I kind of split my work apart if you want to do it like that. Certainly don't have to, but I kind of like to. And figure out where the vertex is first. Because standard form is no good, but vertex form will be. But I don't know where the vertex is. But we figured out how to do that, right? We know that if the vertex is this HK over here, right? A is still A, right? Still the same A. So I know I was going to start. This is going to be A. But I want to figure out what the vertex is. I want to figure out what H is. I got to know that X value of the vertex. But like I can't peek at a graph necessarily, so I need the algebra to back it up. And what we figured out is that negative b over 2a, h equals negative b over 2a, is a really nice, easy way to find the x value of the vertex because we know what a and b are. Now, c we don't really use much in this kind of setup. C is the y-intercept, right? I don't really care about the y-intercept, I want the x's. So I'm just going to change my little fraction there for h to actually have a and b put in those spots, right? So I go back to this, and I always just kind of get in the habit of saying a equals b equals c equals, because I know I'm probably going to use some of them, or if not all of them. Okay, cool. So there's b right there, so 6, but I want negative b, so okay, negative 6 goes on top of that fraction. Okay, and on the bottom goes 2 times whatever a is, and a could be anything, so we want to make sure that we're putting the right number in. A is just 1, so that's nice, and we'll see that just for now. A will kind of always be 1 today, tomorrow, probably Thursday. We'll change a up just to see what that does, because by then hopefully we'll have this down a little bit better. All right, cool. Now I just take that fraction and I just make it as nice as I can, right? All right, 2 times 1 on the bottom, it's just 2. So let's call it negative 6 over 2. And if that fraction was not so nice, then I would just leave the fraction. Or if it ended up being a nicer decimal, you know, a decimal has an end, cool, I'll use that decimal. But this is even better. Negative 6 divided by 2 is exactly negative 3. Perfect. I know what h is. Okay, I know the x part of this vertex is negative 3. Now, I just got to find the y that goes with it because I need k. All right, that's what I'm going to figure out next. I got to figure out what k is. And the best way to do that is just plug it back into the function they gave us, right? I know that for any x, x squared plus 6x minus 1, in this case, it's going to give me the y value that goes with it. And that's what I want for this one, right? So instead of x squared plus 6x minus 1, now wherever there's an x, I'm going to drop in that number at negative 3, and I'm going to see what I get. Use parentheses whenever you substitute. That'll kind of take care of any calculator mistakes that happen by dropping in negatives and then adding exponents to that. Sometimes negatives will get screwed up that way because the calculator likes to read things a certain way. It's programmed a certain way. So, but this whole right side can all go in the calculator all at once. You can do it step by step. If you really wanted to do this out by hand, great. You can do that, but we've got calculators, let's use them. So whether you jump on the Desmos or you use your graphing calculator or you take out your phone's calculator, type in that whole right side, parentheses and all, right, with the negatives, and see what you get, okay? And what would happen, just for the sake of working through this a little bit faster, you'd get negative 10. 9 minus 18 minus 1. Negative 10. Right? That's awesome. I need that, right? I got to know what k is because this is my setup, right? That's what I want to get to. I want to be able to rewrite this left side so that it's got a, h, and k in it rather than a, b, and c. Because a, b, and c, you've got x's and x squareds, and that's no good. So let's do it. Now the work actually starts. Like, all right, I got to here, stuck. Now what? All right, do a little side work, find that vertex. Now I can use it. And so what I'm going to do is I'm going to rewrite this left side like this. A, and you don't necessarily have to write this general form. I'm just showing you so you can see the connection. That's my goal, right? Is to make it look like that, where a number goes in for A, a number goes in for H, and a number goes in for K. Because there's only one X in that whole problem, and now I'm good to go. So I just drop them in. I just drop in whatever those numbers are. A is still the same A, that's why we use the same letter. Now that's a 1. I'm gonna write it right now, but multiplying by 1 doesn't change anything. So in like 30 seconds, I'm gonna erase it anyway. But it's there, so there's a 1 there. The reason I'm putting it there is because when it's a 2, or a 5, or a -3, or whatever it's gonna be by Thursday, we're gonna need it in that spot anyway. So we'll put it there. Okay, x minus whatever h is. What we figured out is that h is -3. Okay, so, but if I put minus -3, I've got 2 negative symbols next to each other. And that seems silly to put 2 signs next to each other. Let's put them together. And when you put negatives together, they make a positive, right? You got 2 negative symbols next to each other, combine them together, and you get a plus sign. So this is really x plus 3 squared, right? Rather than saying x minus -3, which is just silly, let's call it x plus 3. Okay. Cool. Plus k. Okay, so plus, well, plus -10. And again, it seems so silly to put 2 signs next to each other. Let's take the 2 signs and combine them together, right? 2 positives make a positive, 2 negatives make a positive. But when your signs are different, right, plus a negative or minus a positive, that's just subtraction. So I'm going to say minus 10. Okay, and I get myself to there. Again, I'm not going to put the 1. I'm going to get rid of it right now because what's the point? Right? I'm not going to divide by 1 later, so let's leave it like that. Okay, now's the time where I got to stop and see how you're doing. Does that make sense? We cool at that point? Like, give me a thumbs up, give me a head shake, give me a form of life. All good?
Really fast, I just have a question on
Please,
how you got that plus 3.
Yeah.
So what makes it a plus 3 instead of it just being a -3?
Good. Because the general form for vertex form is always x minus h, because remember, horizontal transformations are backwards, so we always use minus to make it go backwards. It's minus -3. So like what's happening in here right now is like x minus -3, right? There's the minus right there, and there's the negative because that's what h was. It was already negative. And when you have 2 negatives next to each other, they always combine to be a positive. This way I only have 1 sign in there instead of 2 next to each other. Cool?
Yeah, cool, makes sense.
Awesome. Okay, so if we're good to there, now it's just solving. Now we can actually start getting x by itself. And all that takes is working backwards through order of operations. Any addition, subtraction on the same side as x, we'll do the opposite. Any multiplication on the same side as x, we'll do the opposite, get it away. Any exponents, we'll do the opposite, right? And so I've got this minus 10 right here that I can move. This plus 3 that's inside, I know it's addition or subtraction, but it's trapped, right? Inside the parentheses with something way more powerful, so I can't undo that until I get all the way back up to the top. But I can take care of this minus 10 that's on the same side as x. That's what I want to do. I want to get x alone. So I'm going to move all the numbers one at a time to the other side by doing the opposite. I've got a minus 10, so let's add 10. Okay, if you want to put the plus 10 on one side, plus 10 on the other, love it. You want to put the line underneath, love it. You want to cross out the 10s to make sure you remind yourself that they go away, love it. Okay, whatever you need to do to get yourself starting to solve this equation. Okay, right side, of course, is just 10 because we just added 10 to nothing. And then the left side, we just kind of bring down whatever we haven't touched yet, which is that whole x plus 3 squared. And I'm not just going to bring it straight down. I'm going to slide it over so that it's a little closer to the equal sign, so I'm using my space a little bit better, right? Try to kind of line up the equal signs. It's never going to be perfect, but just to try to stay organized and neat so that I can keep track of this. I don't care how much space this takes up on your paper. That's up to you. I just want it to be easy for you to follow along. And you can see I do like equation, step, equation, step, equation, step, equation, step, until I get down to x. Cool. So addition and subtraction, done, right? So maybe you have this little germ dots down right here. Okay, cool. Addition, subtraction, that's always my first one. That one's done. Now I move up the step in the ladder, and I would undo any multiplication or division, which would be sitting out here, right on the outside. Either it'd be something being multiplied or something being divided. But remember, the only thing that was being multiplied through was 1. Right? And so we know we don't need that. I don't need to multiply by 1 because that doesn't change anything. So I'm certainly not going to divide by 1. So that step's done. I can just skip it for now because A is just 1. When A changes, that's when, like right now is when I would, like if this was a 2, okay, cool, I'd divide both sides by 2, right? That's what I would get to. But we're good, not to worry about that. So I can kind of move up, next level, and take care of any exponents, okay? We've got that power of 2. We've got something being squared. So I got to do the opposite of that. The only way to undo something squared is to do square root. Okay, so I'm going to take the square root of that whole left side. So underneath the square root, x plus 3 squared equals, and then take the square root of the right. Okay, but remember, anytime we take a square root, we need that plus or minus out in front. Now, the reason I don't even bother with the plus or minus in front of this square root is because the square and the square root are going to cancel each other out. That's the whole point in doing the square root on the left anyway. I only really need it on the right-hand side in front of that number. Reason why we keep track of that plus or minus is because there's a possibility that we have 2 x-intercepts. One that uses the positive version of the square root and one that uses the negative. Right? Because 3 squared is 9 and negative 3 times negative 3 is also positive 9. So when we take the square root, when we do it, we always drop this plus or minus in front of that square root. Let's see what we get, okay? So that's like my step of work. You could, if you really wanted to, like you could have put the square root over the top of your equation there so you weren't using a whole line of work. That's up to you. If you can keep track of that, I'm good with that. I always just like to do equation, step of work, equation, step of work, equation, step of work until I'm done, okay? And the whole point, like I said, in doing this whole square root thing is to get rid of that square. And perfect, done. I did it. I took the square root. So the square and the square root disappear from the left-hand side, just like the minus 10 and the plus 10 both disappear. Same thing here. So I'm just left with that x plus 3 on the left-hand side. I don't even need the parentheses anymore because the squared is gone, and that was the only thing out here that was necessary to keep the parentheses going. All right, cool. Plus or minus, and then square root of 10. Well, maybe you know your square roots really well, and maybe you don't, okay? But what I know is that like 3 squared is 9, not enough. 4 squared is 16, oh, that's too much. All right, so my number's between 3 and 4 somewhere, but is it a nice one or is it not so nice? And I don't know. I really don't unless I plug it in. And so I jump into my calculator and I let it do that discovery part for me. Because if you remember, I think I did this on Thursday, like some decimals even have really nice square roots. Yeah, they're gonna be decimals, but like 2.5, okay, great, that's a real perfect number. I just don't wanna see decimals that go on forever, right? Like square root of 10, you plug that in your calculator, you get 3.1572639 whatever it is, I don't even know off the top of my head, but it's ugly. Right? It's this decimal that never stops and there's no pattern to it. And so instead of stopping and rounding or trying to write down every single number, let's just write down the perfect version of the square root of 10, which is the square root of 10. That tells the whole story that we need. Right? When I say square root, it's what number times itself is 10. Well, that one, whatever it is, I don't care what it is. I just know it's exactly that. Okay? Exponents and radicals, done. Now I finally get myself to the top of order operations, and I'm inside that parentheses. I'm inside that grouping symbol. Now finally I can deal with this plus 3 by doing the opposite. Okay, which is minus 3. Now when you write your answer for this, you've got two choices, right? Putting the nice number up front, that negative 3, and then putting the plus or minus square root of 10 at the end, which is the one I like, which is why I'm boxing it in right now. Or, and you could do it if you want, you write it in the order it's written in vertically, plus or minus square root of 10 minus 3. Either one's fine. You're going to get full points either way if you get yourself to here. The tricky part about this is that some people put that square root and they make it go too far. Or they forget the plus or minus, or they put the plus or minus in front of the 3. You know, it's up to you how you want to write it, as long as you write the right answer. I don't care what order you do it in. This is the nice one, though. Nice number up front, not so nice stuff at the end, and that's perfect. And you don't even need to plug that in the calculator. Just write it and leave it just like that. Negative 3 plus the square root of 10, negative 3 minus the square root of 10. Those are our two perfect x-intercepts. Okay? And that's the idea. We get to this equation that we can't solve. I can't factor it. So what do? Here's one option. Okay? Find the vertex, rewrite it in vertex form, then solve it. Rather than trying to factor and solve, we use vertex form and solve instead. Okay, that was the first one from your work from Friday. Questions on that one? All right, equation, step, done. Sweet. All right, I'm gonna do one more. Make sure you're good. The classwork for today is already up, ready to go. In case you are feeling like, Rosie, I definitely got this. I do not need to see you do another one. I've got it down. I can do my thing now. I think I can do it. Go ahead and get started. You can mute me for right now and just knock that out, okay? Once I'm done with this one, obviously, hopefully by that point, everybody will be ready and they can feel like they can get that one done. But I'm going to work through the other one a little bit faster because I don't have the steps over there on the side, but it will be the exact same process. So feel like if you're ready to jump into it, go for it. But I do want to make sure that anybody that wants to see the second one worked out, especially if you didn't get a chance to do it on Friday, that you see it done so you can make sure that the work that you're submitting looks good. All right, here we go. Stop me if you need me. G of x this time, x squared minus 4x plus 2. Okay, and I know I don't have the steps up, they're over there. I just wanted to make sure I could leave both of them up so I can go back and forth for anybody that needs to see both. First step, set it equals 0. They're asking for x-intercepts. I know I'm going to drop the g of x. And on the right-hand side, set this thing equal to 0. And I would love to factor. Like if I could figure out, okay, a equals 1, b equals negative 4, c equals 2. I always write those down. It's just a good idea. Two numbers that add to negative 4 and multiply to positive 2. Let's see, multiplying to 2. The only way to do that is 1 and 2, or negative 1 and negative 2, and neither of those are going to add up to negative 4, so it's not factored, which is fine. Doesn't mean there aren't x-intercepts. I just know that they're not going to be perfect, nice whole numbers, or even decimals that have nice ends to them. So I can use vertex form. And so I just kind of come up on the side here, and I figure out whatever h and k are by using my super quick little negative b over 2a formula for h, and then I'll plug whatever that number is, once I get it, back into the function to find k. Okay, so h is negative b over 2a, so negative b. Well, b is already negative, right? And remember, that negative there really means give me the opposite of whatever you've got. And so if it starts positive, okay, make it negative. But if it starts negative, switch it, go back to positive. So the number on top of that fraction there is a positive 4, not negative 4. Okay, always switch the sign. Okay. On the bottom goes 2 times a. Okay, 2 times 1 again. Okay, we're going to keep it like 1 for now. Okay, I don't need the h equals just yet because I'm going to simplify a little further. All right, 4 over 2, right, because 2 times 1 is 2. And if that fraction was gross, I would just leave it or simplify it. If it was a decimal, I could use that. But 4 over 2 is perfect. It's exactly 2. Great, I'll use that. Okay, now I take that and I plug it in. You want to know a y value goes with any given x value, and they give you a function, just drop it in. Right? Drop it in this case, to g of x. See what you get. So something squared minus 4 times something, right, plus 2. Wherever there's an x spot, just drop that in parentheses. See what you get. I know that it's not negative, so I shouldn't have to worry too much about it. But now what I've got by setting it up like that with parentheses is I've got a perfectly written way to type it in the calculator. And if I give myself a way to type it in perfectly, then I don't have to worry about the calculator making mistakes that I didn't mean for it to, right? Okay. Plug that in, see what you get. 2 squared minus 4 times 2 plus 2. What you would see, if you typed it in correctly, is you would get negative 2. A lot of 2's in this problem, not intentional, but that's kind of the way it works out. But there you go, there's h and k. And so if I'm writing a x minus h squared plus k equals 0 instead, again, you don't have to write that step in blue. I just like to show you kind of where my numbers are coming from. Right? A is 1, I'll put it there just for good measure, just for these 30 seconds or so. Right? X minus whatever h is. And so if x minus h, x minus 2, great, I don't have those negatives next to each other like I did before, so great, x minus 2, perfect, just like that. Don't forget the squared, that's what makes it quadratic, that's what makes any of this actually work. And then plus k. Okay, so plus a negative 2, all right, so really minus 2. There's all the 2's in there. Again, I'm dropping the 1 at the front. I don't need that, so why drive myself crazy? Cool, there we go. The prep work's all done. Now I'm ready. Now I can just jump in and knock this thing out, okay, by starting to solve. Any addition subtraction by itself is where I start, so I can take care of that minus 2 by doing a plus 2 on both sides. The negative 2 and the positive 2 will cancel out. Right side, of course, is just equal to 2, and I just kind of slide the x minus 2 squared a little closer to that equal sign so things stay as organized as I can. Again, if there was an a value, I would divide it away right now, but it's just 1, so no sense in dividing by 1 because nothing will change. I'm ready to deal with my exponents by doing the opposite. And if it was a power of 3, I would use a cube root. If it was a power of 7, I'd use a 7th root. This is a power of 2, right? It's something squared, so I take the square root. And I really take my time here, and I probably write more than I need to by writing that step in red. If you wanted to just drop a square root over the top of these, you can. The thing that I really like about this step in red is it gives me a chance to put the plus or minus in front that maybe I wouldn't have had space if I tried to squeeze in the square root right there. That's kind of what I'm trying to avoid. Because where do I put the plus or minus? My equal sign is right next to it. So I like to really take my time and take equation step, okay? Now I can rewrite this left side really nicely, all right? Just x minus 2. Parentheses are gone, square root and square root cancel each other out. And then the right side, plus or minus, and then I just plug in square root of 2 and see what I get. If it's nice, I'll use it. If it's not, then I'm just going to call it square root of 2. So I type it in, calculator, square root of 2, enter. It's like 1.37, blah, 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 blah. It goes on forever. So, la-da-da, square root of 2 it is. I like it. Perfect. Because that's perfect. I don't want to round if I don't have to. Now I can add 2 both sides. X, let's do it blue. X equals, again, nice number up front, and then plus or minus the square root of 2. It's a positive 2 since we added 2 to both sides. I don't need the plus in front of it, right? X equals 2 from the plus 2 in red. Plus or minus the square root of 2. I like that one. I'm going to box that one up. But in case you want to put it in the order it's written, plus or minus square root of 2, and then plus 2. There you go. Okay, and you can see, hopefully you heard a very, very similar process that I just did for number 2, exactly what I did for number 1, okay? If I'm gonna ask you to factor something, it's gonna be factorable. If I ask you to rewrite it in vertex form, it's probably not, right? Because this part's necessary. So I'm going to help kind of give you that direction as we start looking at preparing for whenever it happens, relatively soon, certainly once we get back to hybrid, an actual test for what this stuff looks like. And so you have to do it all. Now, when it comes to test time, you have the opportunity to use notes, okay? But I will reward the people that do not, okay? So last year I did it one of two ways. I either said, okay, you can use your notes and whatever grade you get is a grade you get. But if you don't use your notes, if you come into class prepared, you've got the stuff down well enough that you studied, you practiced, you're good to go, then I'll throw you 5 or 10 points on top of whatever grade you get, okay? Or the other way that I've done it is, okay, don't use your notes, you get whatever grade you get. But if you do use your notes, I will cap your highest grade at like a 95 or a 90 or something like that. So, the 5 or 10 point swing one way or the other just depends on the kind of stuff that we're doing. So, but we are certainly a ways away from that. So I won't have to worry. Don't worry about that part yet. Just start to get this idea down, okay? And the best way to do that is to try these 2 practice problems right now, okay? So if you go to assignments on Canvas, I didn't put it on the announcement because I wasn't sure exactly how I wanted to do this, but I saw that only, about half of us had the chance to upload their work from Friday, so I knew that we were still struggling. So I wanted to make sure that I took the time to do this. So if you did not submit your work yet for these 2.5A, there they are. Take pictures of the work that you just did as we were working through these, put them up on Canvas for your work for 2.5A. Make sure your name, the date, I don't care if it's today's date, if that's when you did it, put it up there. And then go to assignments because you'll be right there and click on classwork 2.5B. There are 2 problems that are very similar to these 2, very similar process, just different numbers, okay? And you've got this 15 minutes or so that you can work on, okay? It's not due until midnight, so don't feel like you have to rush and get it in right now. But I mean, you've got perfect examples. All you have to do is change the numbers, okay? And I'm happy to help. And so here's the deal. If you want to stick around and just do it and stay on the Google Meet, great, I'll be here. And this way I can answer questions if they come up. But if you're like, nope, I'm good, I've got it, I'll get it done before midnight tonight, you are free to leave, okay? I want to give you that break in between classes if you can, okay?
Thank you.
On the schedule for tomorrow, class starts a little bit later than usual, okay? So just make sure that you're there. But go to that first or second period class right at 7:40 so we can get registration stuff taken care of, all right? Stick around if you want, otherwise I will see you tomorrow. Thanks, guys.
So I have not necessarily a question, but it does, I guess, relate to next week when we go back to, I guess, hybrid.
Yeah.
I will not be able to make it. I'm getting my wisdom teeth pulled on that Monday.
Nice.
So I probably, I will be hopped up on meds.
I had all something out too. I know the feeling. Yeah. So I will always, if with an asterisk next to that, always, I will try to record every lesson, even when we go back to hybrid, because people will be staying online, right? Because I have people that will be live streaming in every day. And then, people like you that, you got doctor's appointments, you got wisdom teeth, you got driver's tests, you got stuff that happens. I don't want you to feel like you're missing out on anything. So I will do my best to try to record the lesson so that you can watch it a few days later when you are a little more of sound mind. Yeah, I remember those days of just literally doing nothing. The best way for your body to heal quickly is to not move, because you have these holes in your face now where your teeth used to be. So it's an easy procedure, but it just feels weird for sure. You've got these gaps in your gums for time. So hope it goes well, and I will do everything I can to help get you caught up once you're ready. So just keep me in the loop. Tuesday, Wednesday, Thursday, once you're starting to feel like you're able to get on your feet.
Mm-hmm.
Thanks, Joseph.
Rebecca, my sister says hi. He's been sitting here waving at you.
Who says hi?
Rebecca, my sister.
Hi, Rebecca. How's it going?
It's pretty good. I just got my wisdom teeth out, so.
Man, this family going through it, huh? I think this is kind of when I got mine out. So I got like junior, senior year. One of my wisdom teeth was impacted, so they had to knock me out completely in order to take it out. But so I got them done separately. I got like my 2 easier ones done, where they just gave me the local. So I was awake, but I couldn't feel anything. But I could hear everything. Like I could hear my teeth crunching in. It was so weird. But the other 2, they knocked me out. And so they were like, count backward from 100. I was like, 100, 90, and I was just gone. But what's weird about anesthesia is like, you feel like you blink and you just wake up. Like you're not sleeping, but it's like I went out and I was awake and suddenly, like it was an hour and a half later or 45, whatever it was. My face was full. Felt really weird. And when you come out of that anesthesia, your sight is all screwed up. So I remember like they sat me in a chair in this tiny little room and they pointed me at an electrical outlet. And they said, you can leave when you can only see 1 electrical outlet instead of the 2 that you're seeing right now because your eyes are like, because you feel so weird. And so like my mom had to drive me home because you obviously can't drive after that. But I was like, it was crazy. But then I sat on the couch for 2 days, ate ice cream, watched terrible daytime television because early 2000s, that was my choice. I watched old movies on VHS and DVD, I think. And then I was better. So hopefully it goes well. Rebecca, how are you feeling? You feel good?
Yeah, I've been laying down. And then but now I got up to try to do my classes and the medicine actually hit me because I hadn't been feeling it because I was like laying down the whole time. So like when I got up and I was all like,
head starts spinning for sure. Yeah, the less you do, the faster your gums will heal. Your gums are so sensitive that like the bleeding for me took forever to stop. So I just had this mouth of pause for like a day. It was terrible because I'm not really good at laying around and doing nothing. I've never kind of been that guy. I've always just been all over the place. So my parents were just like, just stop moving, just sit down. And I'm like, oh, I want to get up. And so I remember that quite fondly. But are you going to be a senior next year? Is that happening? My goodness. What math class next year? Did you make a choice yet?
No, I haven't made a decision, but I wanted to take another class with you, but I don't think I'm